Welcome back. So this is where we left off. We were able to declare a few variables, a few primitive data type that are based on primitive data types. So the variables that we declare were num1, num2, num3, and my letter, okay, where num1 and num2 were integers, num3 was a float, and my letter was a char. And we were able to assign values according to their nature. For example, if they're integer, then whole numbers for num1 and num2. If you have a float, then a decimal point is admissible. And then we were able to assign also a letter to the variable. Now, printing basically means go ahead and look at the content of that variable and print out the payload. Now, how much memory any of these variables is occupying? That's the key. We want to know, for example, num1, how many bits or bytes does it occupy? Based on the fact that it's an integer. How about num3 since it's a float? How about char since it's a character? Now I've mentioned before that integer is 4 bytes, char is 1 byte, and we're going to see what float is. But let's look at them all. So I'm going to add one more section to my program here where we'll look at, so let me write a comment here. So print the size in bytes occupied by each variable. Okay? So what are we going to use? The technique for that, we're going to use a function that's in the library called sizeOf. We will use sizeOf as a function, and it will take a parameter, which means it needs an argument, and I'll show you that in a minute. Just like printf takes a few arguments, right? System takes that string pause as an argument, right? Okay, so let's see how this works. So let's go ahead and printf. And I'm going to say something like this. Num1 occupies %d bytes in memory. /n. Let's start just with that first and try to understand what is it we're trying to do. We want to see how much space num1 is occupying. And we're going to put a %d here. Okay? Now, why %d? Well, it's not because num1 we want to extract 8, which is an integer, but the fact that the size in bytes is an integer, then you need %d. Right? It's going to be a whole number. You're not going to get a byte and a half. You'll always get 1 byte, 2 bytes, 8 bytes, so on and so forth. Right? So they're going to be whole numbers. And we're going to use the function sizeOf. And notice how it turns bold because it is a keyword. And then you supply it with the variable that you want to find its size. In our case, it's num1. And then make sure you close your curly parentheses and then semicolon, right? So this here, including this parentheses right here, is a function that returns a value. And that value happens to be an integer, which will be the size of this variable num1. That means how many bytes is it occupying in memory? Okay, well, let's run this program right now and see if we do get 4 bytes. So compile and run. And sure enough, num1 occupies, and let me change that to an S, 4 bytes in memory. Okay, occupies. Okay, how about num2? Same thing. I mean, we could see that it's consistent as long as they're both integers. And then you same technique, %d, bytes in memory. Put a /n, that give me a new line. Put a comma, don't forget that comma, sizeOf, because the comma separates the argument of for the function printf, right? So, and this would be num2 And there you have it. How about num3? Same thing. Printf. Num3 occupies and then that would be a %d bytes in memory /n comma size of num3. Okay, now how about my letter? Absolutely same thing. So printf my letter as a variable occupies %d. Now you can say bytes. I know it's going to be 1, so I'm just going to say bytes anyway. Occupies in memory /n comma size of, and that would be my letter. So you are interested in the space reserved for my letter. All right, well, let's see what the result of this yields. So compile and run. Let me see, I made a mistake here. Let's see, my letter occupies, so did I misspelled my letter. There you go. My letter. I missed an E. Okay. Happens a lot. This is part of programming, so, just pay attention. And let's see what happens. Okay, so for an integer value, we had 4 bytes. Another integer value, we had 4 bytes. For this float, we had 4 bytes. For a character, we had 1 byte. Okay? All right, now, how about a variation? Remember I mentioned something about short int, long int. What if I needed larger floats as well, right? So let's go ahead and do that. Let's see what the size for these subcategories of data types will be. All right, so let's do that right here. So let's do a short int and num4, and let's give it a value equals 8, right? We can actually, so we're going to skip the assignment value, and I'm just going to go ahead and initialize, right? And so we know that's an integer, but it's of a certain kind. So I can print f what that is. So num4 is going to print 8. So %d/n, and that would be num4. Next, we want to know how many bytes num4 occupies. So printf num4 occupies %d bytes in memory /n, and that would be num4. Oh, sorry about that. Size of num4. We're interested in the amounts of bits and bytes occupied. Remember, 1 byte is 8 bits, occupied by that particular variable. So let's compile and run. And there you have it. So short now got reduced to 2 bytes in memory. Okay? So let me just separate this here. I think so let's go ahead and do a long int. Let's do a long int. So long int num5. And this time I'm just going to assign num5 right here. So num5, you could do it any way you want. As long as you assign values after you declare the variable. Okay? So you cannot assign a value before you declare a variable. Keep that in your notes. And let's say we put in 78. And let's see how long is num5. So first I'm just going to print num5 again. So I'm going to copy this, paste this here, and I'm going to make this for num5. And do this for num5. And I'm just going to copy all of this right here and redo it again. But except this time it will be num5. And we're interested in the size for num5. Now remember, num5 is a long int. And remember, a regular int had 4 bytes. A short int had 2 bytes. Well, let's see what a long int is allocated. So compile and run. And you can see here, num5, really nothing changed there. We still have 4 bytes. Okay, how about float? Okay, so it's good to know the behavior of what's going on here. So let's go ahead and do a float. And let's say we do a long float, okay? And let's call this one num6. I'll just make it equal to 0.0. It doesn't matter. And I'm interested in, we know we can print it, so I'm going to skip that part. And I am going to print num6. So it's the same idea here. So copy this and paste. And we're going to look at num6 now. How many bytes does num6 occupy? Make sure you're referring to num6. Now remember, our regular float was 4 bytes. So compile and run. And there you have it. We have a problem. It wouldn't take a long float. So there must be another way. Okay, what could that be? Could we do double? Aha. So let's see if that is a valid data type. So compile and run. And there you have it. So for the long float, if you wanted a longer float, use the variable double. All right, so notice now we've doubled the size of a float. Remember, a float occupied 4 bytes. So now what we have is num6, which is a double, which is really a float type, but much bigger. It takes up much more space in memory. Has 8 bytes. Okay, so I hope you learned a lot from this. Next, we want to know where in memory any of these variables were stored.